Hello, so this is a project that I was assigned to do in class, and it's called a Photogate. And to put it simply, it's a mechanism that marks the time that the photoresistor is blocked and then marks the time where it is unblocked. It's basically a card swiper. When I push the card through, it measures the time when the card starts to block the photoresistor and then when it stops. You can use this information to calculate a bunch of different things, including the start time, the end time, the elapsed time of the card passing through the photoresistor, and the speed in any form of speed you want, inches per second, meters per second, feet per second, whatever. So the electronics are very simple. All you need, it's very hard to show because it's a blue LED right there, is an LED photoresistor. You're going to need a 220 ohm resistor for the LED, a 1000 ohm resistor for the photoresistor. You need a couple of wires to set up a voltage divider with the photoresistor. This wire goes to 5 volts. This wire goes to A0, and it just unplugged, so I shall plug it back in. And then you have the resistor going to ground under the breadboard for ease of use. Great. And then the LED is basically set up an LED. You also need a microcontroller. I choose the Arduino Mega because that's what I prefer to use. It has a whole lot of pins. Anyways, here's the code. So we set up the serial monitor to show us what we want, and then we set up the pin mode for the LED to be turned on all the time so that the photoresistor can measure changes in the LED's readings, and the pin mode for the analog read to show the photoresistor's readings. And then in the loop, we have digital write 10 high to turn on the LED. We want the LED to be turned on all the time. That shouldn't change. Then we have a while statement. While the reading of the photoresistor is greater than 200, so when the photoresistor is not being blocked, you have a while loop and nothing happens. So all the time that it's not being blocked, nothing happens, and it prevents the code from continuing. Then we have a long statement, which basically measures time, and it measures the integer start time in milliseconds. So as soon as it's no longer being blocked, it keeps the time in its head in this integer called start time. Then we have another while loop while the photoresistor reading is less than 200, which means that so when the photoresistor is being covered, nothing happens. After it's no longer covered, you have another long statement, this time with the integer end time, also in milliseconds, and then you also keep that in your head. Then the rest of the code is just printing a bunch of different things. So first we want to print the start time. I set it up for my convenience. We have start time, print the end time, and then we have a float, which is another statement that just allows for basic math equations. You can look all of this up on the Arduino website. You have elapsed time is equivalent to the end time minus the start time, and then you have print elapsed time. Then we have the card length. So I'm using just a regular card that fits in my wallet perfectly, and I measured it with a ruler, and it's 3 3/4 of an inch, 3 inches and 3/8 of an inch long, so 3.375. We're talking about inches because we're measuring in inches per second and feet per second. Out of preference, you can do whatever you want. You just have to measure in the metric system, not inches, not the imperial system. Then we have another float for inches. So we're measuring the inches per second, and 1,000 because it's milliseconds. So 1,000 makes it 1 second times the card length divided by the elapsed time. So distance divided by time equals speed. So that's the equation, and then you print it. And then we want to find the miles per hour. So we find float miles per hour equals inches divided by 17.6, which is basic math. You can search up how many inches are in a foot, how many inches per second are in a miles per hour, and then you get it. And then you print that as well. Then I put then I made just a indentation, another indent, so that you can distinguish between different readings. Then we have a delay for simplicity. Okay, and so here we are. I'll go into the serial monitor. And of course, mind you, that this does not always work because it is measuring light. And light moves around all the time. So you can't always be precise. So I put the card in. And I move it through. The wires are kind of in the way. But I finished moving it through. And that was really slow, but The first time, ignore it because, again, it measures light. It doesn't really work. But start time was 5 seconds. End time was start time was 58 seconds. End time was 59 seconds. Elapsed time is about 5 seconds, as you can see. Inches per second, it was about half of an inch per second. And then miles an hour, it was about 0.03 miles per hour. So again, it was very slow and it took a while, but there you go. And that's the code. I hope you enjoyed.